All right, let's start off on number 1 here. So for this one, nonlinear inequality, we always want to get one side to 0. So I'm going to subtract the 3x squared and the 20 over here. There we go. All right, so that'll become 2x squared, and then that plus 3x is going to stay there, and then minus 20 is greater than or equal to 0. So now I'm going to factor this. So we're going to think of two numbers and multiply to negative 40, since that's a times c, and add to 3. So that sounds like 8 and 5 with a negative 5. I do need to use my grouping technique here, so I'm going to go 2x squared plus 8x minus 5x minus 20. And then we'll go ahead and do our grouping. So then I get 2x times x plus 4 minus 5 times x plus 4. Since I took out that negative, they're both going to switch. All right, so then we get negative 4 right here. Oops, I kind of skipped a step there. Hold up. So I need to write this then as 2x minus 5 times x plus 4. Okay, so now I'm going to go to the number line. So I got negative 4 here. And then this one's going to be 5 over 2. If you can't see that, you can go ahead and set this parentheses equal to 0, and we're going to add the 5 and then divide the 2. Both closed dots here because of the or equals 2. And then we're going to test out some numbers in each interval. So I'm going to test a number over here. It's just got to be smaller than negative 4, so I'll go negative 5. I'm going to plug it into both of these parentheses here. So negative 5 times 2 minus 5, that's obviously negative. Negative 5 plus 4, also negative. And a negative times a negative is a positive. Next up in the middle here, we got x equals 0. We can try any number in there, but 0 is just kind of the easiest in my mind. And so in the first parentheses, 2 times 0 minus 5 is negative, but 0 plus 4 is positive. So this one's going to multiply to a negative. And then we'll try a number out here. You can try any number you want. I'll go ahead and just use 5 to be safe. So 2 times 5 minus 5 is positive, and then 5 plus 4 is positive. So we're just testing whether it comes out positive or negative. Now in this case, because I am greater than or equal to 0, I want positives. And so I'm going to go out here and over here. And so my answer is going to be negative infinity to negative 4 with a bracket. And then also 5 over 2, comma, infinity. All right, next up here, another nonlinear inequality. So we usually on these ones, we set it or get one side to 0 and factor. Now that's already been done for us, so that's nice. So I'm going to go right to the number line. We got negative 4, 6, and 7 here. Now there is no or equals to here, so these are going to all be open dots. And I'm just going to test out each zone. So if you test out, let's say negative 5 here, got to test it into 3 parentheses. So that'll be negative, negative, negative. And so that comes out negative. So I'm just plugging into each one of these on their own and seeing if it comes out positive or negative. So next up, I'll go in the middle here. And for that one, I would use x equals 0. Just once again, you can use any number in between negative 4 and positive 6. So it's going to make the first one negative, second one negative, and the last one positive, because 0 plus 4. So that's actually going to come out to a positive because we have 2 of them. In here, I'll go ahead and use 6.5. And for 6.5, it's going to come out negative, positive, positive. So that'll be negative. And then out here, I'll use x equals 8. So it's going to be all positives. So that's going to come out positive. Now, in this one, we have greater than 0, so we want the positives. And so I'll go in here and then out there. So this will be negative 4 to 6, and then also 7 to infinity. Those are all parentheses. All right, next up here, once again, we'll go with, actually this is already factored, so we'll go straight to the number line. So we're going to have negative 7 and negative 3, both of them open dots. And then I'm going to do some test points. However, I kind of already notice here that since this one is squared, I can actually already fill that in on all of these as a positive. The reason why is since we're dealing with all real numbers here, whenever you square anything, it's going to come out positive. So that one I don't really even need to check. So anytime you have an even exponent like that, those are just going to come out positive. So really I'm just going to be testing in the second one. So if I do something like negative 8, that's obviously negative 8 plus 3 is negative, so that's going to come out negative. And if I try a negative 4, and negative 4 plus 3 is negative again. And then if I try something like 0, 0 plus 3 would obviously be positive, and so that would be positive. So this one again, I got the greater than, so that means I want the positives. And so I'm going to go from negative 3 to infinity. All right, this one we can see once again is already in factored form. So I'm just gonna go to the number line. We got -3, we got -2, and then we got +6. These are all gonna be closed dots here. And so I'm going to have to test here. And but once again, just like the last problem, I see that in each zone, the first one being squared is always gonna be positive. So I can fill that in without testing. And then I just have to test the other two. So, yep, anytime you have an even exponent, you're just going to make that always positive. And so I'll go ahead and test out over here, x equals -4. So that's going to be -4 minus 6, and then -4 plus 3, negative, so that'll make a positive. And then in here, I'm going to have to use like -2.5 in between -2 and -3. So that's going to become out negative in the x minus 6, but it's going to switch to positive here. So it'll be a negative. And then in here, I'll try out like x equals 0. And so that's going to be negative, positive. And so it'll be another negative. And then if I do x equals 7, that'll be positive, positive, which will come out positive. All right, so then the answer on this one, now obviously here we want the positives. And so I'm going to go over here and over there. But since -2 is a closed dot, I need to include that in my answer. I don't want any of the intervals around it, so I'm going to say it's from -infinity to -3, and then union, and then I need to do a little bracket, -2 here. So that's me including that -2 alone, and then from 6 to infinity. So very important, if you have any closed dots, kind of what I call on an island there, you need to include them in your answer. All right, next up here, I am going to get one side to 0. I always like to have my biggest power positive, so I'm going to subtract the 4x over here. And so I'm going to say 0 is less than or equal to x to the third minus 4x. And now we'll go ahead and factor this. So I'll factor out 1x, and then I can break it down some more. All right, so then I'm going to go -2, 0, and 2. And they're all going to be closed dots. And we'll test out x equals -3. Now, in this case, when I have that GCF factored out front, and that's why I have 1 at 0 anytime you have a GCF factored out front, but I need to plug in there as well since it is a variable, so it'll be negative, and then negative, so that's going to come out negative. And here we got x equals -1, and that's going to come out negative, but now positive in the x plus 2. And so 2 negatives makes a positive, and then x equals 1 would be positive, negative, positive. So now we're back to negative because we have an odd number. And then x equals 3 would be positive, positive, positive. So that's obviously positive. Okay, now this one's a little tricky because it's backwards. This actually, in this case, means I want the positives. And that is because you have to kind of read this backwards. Since my variables, my expression is over here, I'm saying my expression is greater than 0. So that's the positives there. And so then I want this zone and that zone. So I'm just going to say -2 to 0, and then 2 to infinity. You can see that I don't need to kind of do any on the island there because I've already included my closed dots in my answer. All right, next up here, we have a fractional expression greater than or equal to 0. Now, it's already kind of one simplified fraction for me, so I'm actually ready to go to my number line, and I'm going to put -2 and 3 there for what makes the numerator and denominator 0. Now, 3 is going to be a closed dot, but -2 is actually going to be an open dot, and that's because it's coming from the denominator. If it's coming from the denominator, it's always going to be an open circle because -2 really makes that expression undefined, so I don't want to include it in my answer. But now I'm going to do those same test points that I did before, so I'll try out like x equals -3 here. And -3 would make the top and the bottom negative, which would make a positive. Now in here, I'll try out x equals 0, which would make the top negative, but the bottom positive, so that's negative. And then x equals 4 would work over here, which will be positive, positive, which is obviously a positive. Now in this case, I want the positives, so I'm going to go over here and over here. So my answer then would be -infinity to -2 with parentheses, and then bracket 3, comma, infinity. All right, next up here, I want to get one side to 0, so I need to subtract this 3 over. So I'm going to say x over x plus 1 minus 3 over 1 is greater than 0. I do need a little common denominator here. So I'll distribute this negative 3, and that'll become x minus 3x minus 3, which I would just simplify to make it negative 2x minus 3 over x plus 1 greater than 0. So now I can go to my number line, and we will go ahead and put on there negative 1. And then this one's a little confusing. I would go ahead and when you have like two negatives like this, set it equal to 0, and we're going to kind of just solve it to figure out what number is going to go on that number line. And it's actually going to be negative 3 over 2. Which is actually further this way. So, yeah, I don't have a number over there because negative 3 over 2 is like negative 1.5. And so I got to put it over there. Okay, so now actually both of these are open. The negative one's kind of open for two reasons, because it's on the denominator, but don't really have to make that choice anyway since it's not or equal to. It would have been open either way. All right, so now I'm going to do my test points here. So I'll try out x equals negative 4. Let's just make it a nice big number there. And that's actually going to make the top positive there, because that'll be actually negative 2 times negative 4 is positive 8 minus 3. In the bottom, it'll make it negative, and so this zone is negative. In here, I'm going to have to do like negative, shoot. I'll go ahead and do negative, I think I want to do a fraction here to make it easier, but what fraction? I'll just use a decimal, negative 1.25. And negative 1.25 is still going to have the bottom being negative. But that's going to make what on the top? That's going to make positive 2.5 minus 3. So that will actually be negative also. So negative divided by negative will be a positive in here. And then I'll try out like x equals 0 here would work, and that'll be a negative over a positive. So that's going to come out negative. All right, so what do we want? We want the, if we look back here, we want positives, because it's greater than zeros. And so that's just the space in the middle, so negative 3 over 2, comma, negative 1. All right, next up here, once again, get one side to 0. So we have 4 plus x over 4 minus x. Minus 1 over 1 is greater than or equal to 0. So I'll do a little common denominator here. We'll multiply this by 4 minus x. And we have to distribute this as a negative 1. So it's going to be 4 plus x minus 4 plus x over 4 minus x. Now if I combine like terms, that actually just becomes 2x over 4 minus x. And that's going to be greater than or equal to 0. And so now I'm ready to go to the number line. I actually need a 0 for the top there since I have 2x, and then also a 4, positive 4 for the bottom because it's 4 minus x. And so that just what makes that 0. For this one, from the one coming from the top, it's going to be a closed dot, but again, the one from the bottom is going to be an open dot because it's coming from the denominator. All right, so now you would do your test points, and I'll let you guys take it from there. All right, next up here, we'll subtract the 6x over. So that'll be x over x plus 1 minus 6x over 1 greater than, oh, not or equal to, just greater than 0. Now we need common denominator, multiply that by x plus 1. All right, and we'll distribute that negative 6x in there. So that's going to become negative 6x squared minus 6x. And then this will actually be that positive x back there. All right, so combine like terms here. They'll give us negative 6x squared minus 7x over x plus 1 greater than 0. Now I would actually factor that. And so on the numerator, I would factor out, I'd probably do a negative x and call it 6x plus 7. And then put that over x plus 1. And so that's going to be greater than 0 still. So we're going to go to the number line now. I'm going to have negative, actually negative 7 over 6 is the smallest number from that parentheses, 6x plus 7. And then negative 1 would be next. And then I'm going to have a 0 for that negative x out front. Remember, if negative x equals 0, that just, if you divide by negative 1, means x equals 0. So anytime you got that variable GCF'd out front, it's always just going to be 0. Okay, so now we'll do our test points. I'll try out negative 2 is fine. And that's actually going to make, if you think of that negative x there, it's going to be positive. On the bottom, it's obviously negative. And then on the top, 6 times negative 2 is negative 12. And so negative 12 plus 7 will be negative. So that'll be positive. Oh, I didn't do it, but these are all open dots because it's greater than 0. All right. In here, I'm just going to do x equals negative 1.01, just a little bit smaller than negative 1. Now on bottom, that's going to come out just a little bit negative. On top, that'll still be a positive in the negative x. And then 6 times negative 1.01 will just be like negative 6.06 plus 7. That's going to be positive now. And so this is going to come out negative. All right, and then next up, we'll do negative 0.5. So that'll still be negative, that'll still be positive in the negative x up there. What is this? Oh, it's negative 0.5. All right, so that'll be negative 3 plus 7 is positive, and now the bottom is positive as well. So this will be positive, and now we'll do x equals 1, which will be negative in now switching in the negative x, but positive in the other two, which will give me the negative. Okay, so I want positive since we're greater than 0, so I'm over there and in there. So pretty straightforward there. I'll let you guys draw your interval notation. All right, next up here, we got another one. So we want to move this all to one side. So I'm going to subtract that over, and then we're going to factor. So I'm going to GCF and x to the 6th power, which will give me x squared minus 1. And then I need to factor that some more. That'll be x plus 1, x minus 1. All right. So now we're going to go to the number line. I need a negative 1, I need a 0, and I need a 1. And now we're going to do some testing here, but I have this 6th power out front. So remember I said anytime that it's an even power, we already know it's going to come out positive. So I can already just fill these in as positives. So I'll go ahead and do that. All right, and then whatever I test out here, it's just everything's going to be positive for that first parentheses since it's 6th power. Okay, so now I'm going to do my testing here in the other parentheses. So over here, I'm going to try negative 2. So that's going to be negative negative in those other two, and it'll come out positive. All right, in here I can try out negative 0.5, and so that is going to make this first one now positive and that one negative still, so it'll be negative. If I try out x equals positive 0.5, that'll be a positive and a negative still, so that'll be negative. And if I try x equals 2, it'll be a positive and positive, so that'll be a positive. So these are all open circles, and then I want the positives because we are, in this case, greater than 0. So I want the positives, so I want it over here and over there. So my answer here is going to be negative infinity to negative 1, union 1 to infinity. So the thing I wanted to show on this one is that this one we have that 0 in the middle there, but I don't need to include that in my answer because that's an open circle. So if that was a closed circle, I would have to do that bracket 0 bracket. But since it's an open circle, I don't include it in my answer, so that's good. All right, next up here, we got an absolute value inequality. So for these ones, we have to isolate the absolute value, which is already done, and then we split it up. So once we just write it without the absolute value, and then once we change everything outside and nothing inside. So I changed the I changed the inequality, and then I also changed the 1 to a negative 1. So now I'm going to solve both of these individually. So this one would be x is less than or equal to 6, and then over here, we'll say x is greater than or equal to 4. All right, so now we're going to draw our number line here. So I got 4 and I got 6. We don't need to use test points for this. We just need to kind of follow what direction these go in. They're both closed, but it says greater than 4 and less than 6. So that's the space in between. Sometimes I'll be shooting to the outsides if it said less than 4 and greater than 6, but this one you can see they're kind of pointing at each other. So it's no arrows, just the space in between. So it's bracket 4, 6. All right, next up here, we need to isolate the absolute value first. So I need to subtract 9 here. So negative times the absolute value of 2x minus 3 is greater than or equal to negative 4. I need to now divide by negative 1. And since I do that, and I'm doing that to isolate the absolute value again, I do have to flip that sign because that's our rule for inequalities since we divided by negative. And now I'm going to split it up, and it's going to turn into a kind of very similar to the last question. So I'll let you guys handle that. All right, next up here, we have a rectangular garden. It's 6 feet longer than it is wide. The area is 475. Okay, so I'm going to make my rectangle here. I know the area is 475. And then I know that it's 6 feet longer than it is wide. And so I'm going to say x times x plus 6. All right, and so I know then that the area equals the length times width. And so that's going to be 475 equals x times x plus 6. So this is quadratic, so I need to get one side to 0. So I'm going to distribute that, and then I'm going to subtract the 475. Okay, and so now we will make our diamond here. So we got negative 475 and 6. So what multiplies to make 475? All right, so I would try all numbers that end in 5 here. So we have 5 times 95, not going to work. Let's try dividing it by 15. That's a decimal. Let's try 25. 25 and 19. That sounds great. Okay. So then we get 0 equals, it's got to be a negative 19, so x plus 25, and then x minus 19. So x could equal negative 25 or positive 19, but since it's a distance, it's really going to be the positive version of that number, so we'll go 19, and the other one's going to be 25. Now, it said that it's 6 feet longer, so the length is the longer one, so just keep that in mind. So that's going to be the 25, and then the width is going to be the smaller one, 19. All right, next up here, we have some geometry problems. It has my answers listed, but that's okay. So I'll show you how I would set these up. So we know that the total area on the first one is 120. So I'm going to say 120 equals, and then I'm going to say the area of the triangle plus, actually, this is not really what the triangle looks like. I'll draw it like it looks. So the triangle plus the square. And so I know that the square area is just y squared. And then the triangle area, since this is also y, and these meet at a right angle, we can do 1/2 base times height. And so that's 1/2 times y squared. And so really what they're saying here is that 120 equals, we'll call that 3 over 2 y squared. And so what I can do is just multiply this by 2 over 3. And I'll get y squared equals, let's see, I should be able to do that. So that'll be 40 times 2 is 80. And so then we take the square root there, and y equals technically plus or minus, and it says 2 decimal places, so I'll say 8.94. But since it's a distance, we're only going to say it's positive 8.94. That's where they get that. Okay, and then so very similar here. This one is 1104 is going to equal, let's see, the triangle plus the rectangle. And the triangle area will again be 1/2 y squared. The rectangle on this one will actually be y, because it's really 1 times y, the length times the width. So that's that. Now on this one, I would multiply it by 2 and then get everything to one side. So I'm going to say 0 equals y squared plus 2y minus, because I'm going to subtract over, and that's actually going to be 2208 when I multiply that by 2. So now you would just factor that with the negative 2208 and then the positive 2. So that is a pretty big number there. Let's see what I would try. 2208 divided by, try 12. Actually, that's way off. 12 and 184. Okay, so let's try another one. Let's try like 18. 18, still too far away, and it's a decimal. So I'll try 24. 24 and 92. All right, so I'm going to keep going. I'll try 36. That's the decimal as well. Let's try 48. Aha, 48 and 46. So once I got in that number family, I figured it would be something in there. So it'll be a positive 48 and a negative 46. So then we would get 0 equals, actually I'll do that over here. 0 equals x plus 48 and x minus 46. So x could equal negative 48 or positive 46, but since it's positive, we'll say it's 46. It's actually y, but you just type in 46 there. All right, next up here, let's see, they gave us the dimensions, and they say the perimeter of the mat is 110, and so I know the perimeter is 2L plus 2W, and so then I know here that this is kind of an x more that way and an x more that way. So then I know the length is 2x plus 15, and then the width is kind of the same thing, an extra x on each side, so 2 times 2x plus 20, and then that is going to equal 110. So then you're just going to solve that for x, and that's it. All right, next up here, it says a plumber and his assistant are working together. He charges $35 an hour, and then for the $25 for the assistant, and then the bill comes out to $3,800. So for this one, we can say 25x plus 35x equals 3,800, because that one has all to do with money. Now, I don't have a, oops, not, shoot, this one of these should be y. So y is the plumber. So we make those different variables. So then, it doesn't say how many hours they work, so I don't have an x plus y equation, but it says the plumber works twice as long as his assistant. So what I'm going to say for that one, I'm going to compare the plumber and his assistant. His assistant is actually x, and so since the plumber works twice as long, I have to multiply the assistant's hours by x to get to the plumber. So remember that x is the assistant, and then y is the plumber. So even though the plumber worked more, remember when we do these comparison equations, I have to multiply the other one by 2 to get to the bigger one. So then we'd use a substitution here, so we'd swap that out right there. So it becomes 25x plus, and then 35 times 2x equals 3,800. And so that would be 70, and then 95x equals 3,800. So for me, that's going to come out to, divided by 95, x, 95, and x would equal 80. And then so the plumber, oh, sorry, no, it wouldn't, it would equal 40. So the plumber, that's the assistant, so the plumber worked twice as long, so it would be 80. All right, next up here, I got a money equation, so I'm going to do my nickels, dimes, and quarters. So I got 400 equals 5x plus 10d plus 25q, and I kind of just made that all in terms of cents, so I could have whole numbers there. It says twice as many dimes as quarters. Okay, so twice as many dimes as quarters. So I'm going to compare the dimes and the quarters, but there's twice as many dimes, which means I need to multiply the quarters by 2 to get to the dimes. And then it says 58 more nickels than dimes. Okay, so if I compare the dimes and the nickels, I have more nickels, so I have to add 58 to the dimes to get to the nickels. All right, so then I'm ready to do some substitution here. Oh, shoot, this one, that should have been 5n. All right, and so I want to get everything in that first equation in terms of the same variable. So what can I turn everything into? Let's see, I can turn everything into d if I switch this equation to say q equals 1/2 d. All right, so now I can do some substitution here. So I'm going to make this now the first equation. We'll say 400 equals 5 times d plus 58 plus 10d plus 25 times 1/2 q. So if I kind of simplify that, 5d plus, let's see, what would that be, 280, plus 10d, plus, I'll just call this 12.5q. And then you'll just combine like terms and solve that for d, and you can just plug it back in to find your other variables. All right, next up here, we have an absolute value inequality. But this one's actually kind of a trick question. Normally I would split this up at this point, but I can see whenever there's an absolute value dealing with a negative, that's kind of a special case. And so I'm kind of thinking here, when will an absolute value be less than a -8? And that seems like never, so I'm going to say no solution. Now, if that's a greater than -8, I would say negative infinity to infinity. But just kind of got to be logical about that one. An absolute value can't be less than a negative. All right, here we have another nonlinear inequality, and so this one, it's already factored all for us. That's really nice. I might have a -9 here. I got -3 there, and I got 0 there for the x squared. I know x plus 9 shows up twice, but I never put a number on my number line more than once. So the dots here are going to be open, open, and then closed. So remember, any number that's coming from the denominator must be an open dot because it may not be included in our answer. So that's why I did -9. Even though it's on top, on bottom, and bottom, if it's in the denominator, that is an excluded number, so we cannot include it. Okay, so now I do need to do my test points here. I have 4 parentheses. Now the kind of trick on this one is, since I have that squared like I've been talking about, it's going to be always positive. So I'm really just testing out the other numbers. There are the other factors, the other parentheses. So I got positive up there. Okay, and then when I go here, I get x equals -10. And so that's going to be a negative, negative, negative. So 3 negatives makes a negative. If I try something out like x equals -5, -5 plus 9 is positive, but -5 plus 3 is negative, so that's going to be a negative, 1 negative. If I try out x equals -2, it's going to be positive, see, everywhere, so that's going to be a positive. And then if I try out x equals 1, that's going to be a positive everywhere as well, so that's going to be positive. Okay, so the less than or equal to 0 means we want the negatives, and so I'm going to go over here and in here. However, I'm kind of already keeping in mind that I need to include 0 in my answer because that is a closed circle. And so I'm not allowed to combine these two intervals because they're separated by an open dot. So I'm going to say -infinity to -9, union -9 to 3, sorry, -3. And then I'm going to go union bracket 0. So I need to include, like I said, I need to include that 0 there just by itself. I don't want any intervals around it. So that's going to be my answer right there. All right, next up here, I want to factor this one. So I will go x to the 12th minus x to the 10th. I'm going to get one side to 0 first, and then we'll factor out x to the 10th. Give me x squared minus 1. And we go x minus 1, x plus 1 greater than or equal to 0. So I'll go to my number line here. I got -1, I got 0, I got 1. They're all going to be closed dots here. And then I'll test out. Now, again, I got that positive, or sorry, I got that even exponent in the front. So even exponent will always be positive. So I'm going to kind of do a little shortcut there. And then we'll try out like x equals -2. So that becomes negative and negative. I'll try out x equals -0.5, which will be negative, but now positive. And I'll try out x equals positive 0.5, which will still be negative, positive. And then x equals 2 will be positive, positive. So I want the positive, so I'm over here and over there. But once again, I got that floating 0 in the middle. I need to include that in my answer. So we got -infinity to -1 with a bracket. And then 0 on an island. And then 1 to infinity. All right, this one we need to factor completely. I would use a u substitution for this. Let u equal x minus 8. So we'll say u to the 7/2 minus 64 u to the 3/2. And so I'll GCF u to the power of 3/2, which will leave me with u. And then if I'm taking out the 3/2, 7/2 minus 3/2 is going to give me 4/2, which is just squared. And then this one will just be left with the 64. Now I can actually continue to factor with u, and so I'm going to make that u minus 8, u plus 8. But now I need to plug back in, so let's remember that u is x minus 8, so I got x minus 8 to the 3/2. And then I have x minus 8 minus 8, and x minus 8 plus 8. So if you simplify that, this would be x minus 8 to the 3/2 times x minus 16. And then this one, these will actually cancel out and just leave me with x. I always like to put that x out front. You don't have to, but I always like a GCF, which that has now turned into a GCF. I like it out front. All right, next up here, I'll do some more u substitution. U equals x squared plus 1. So I'm going to write this as u to the 1/2 plus 8u to the -1/2. And so I'm going to GCF again here. So we'll GCF u to the smallest exponent, which is -1/2. Now, remember that when we GCF a negative exponent is actually going to get bigger, so 1/2 minus -1/2 will actually become 2/2, so this will be u to the first, and then this one will just turn into 8. So I would always drop this negative exponent down to the bottom, and then I'm actually ready to plug back in, so this will become x squared plus 1 plus 8 over parentheses x squared plus 1 to the 1/2 power, which I would just simplify to x squared plus 9 over x squared plus 1 to the 1/2 power. Now, I'd say that's fine. If you wanted to change that to the square root of x squared plus 1, that's also fine. But one thing I wanted to point out is that even if you do that, you cannot call this denominator x plus 1. You can't square root these individually because of the addition in the middle. You can never, ever do that, the square rooting individually when you have adding or subtracting inside. All right, next up here, they want us to find the common difference. And so that's just kind of, if it's arithmetic, what's kind of the pattern here, what's being added each time. So I can see that it's positive 3.5 since it's being increased by 3.5 each time. So if I add 3.5 one more time, that's going to give me my a sub 5, which will be 49. And so a sub n then, for a sub n, I always call this dn plus a sub 0. I think of it like mx plus b. And so the common difference we know now is 3.5. And then the a sub 0 is like hypothetically what would the term in front of the first term be. So if I subtracted 3.5 from that, let's see what that would be. It would be 31.5. And then, so that's my answer here for a sub n. You can always test that if you plug in the 1. So if I plug in 1 here, 3.5 plus 31.5, that should give me the first term. If I plug in 2, so 7 plus 31.5, that gives me the second term. So that's something you always kind of need to check on those when you're writing them. If you have the list, plug in 1, plug in 2, and make sure it predicts those accurately. So now for a sub 100, I would just do 3.5 times 100 plus 31.5. Whatever that answer gives me is going to be that answer over there. All right, last one here is asking for the first 5 terms of the sequence, and it's giving me the recursive formula. Now, the recursive formula means that, remember, this a sub n minus 1 is always referring to the previous term. So if I already know a sub 1 is 5, but if I want a sub 2, it's going to be 2 times parentheses the previous term plus 4. So that'll be 2 times 9, it'll be 18. Now, if I want a sub 3, and to kind of visualize this, I'll just draw this arrow there. So a sub 3 would be 2 times the previous term, which is now 18 plus 4. So whenever you see that a sub n minus 1, that's just saying plug in the previous term, and that's what you get. So this will be 22 times 2, so 44. So a sub 4 then would be 2 times the previous term, which is now 44 plus 4. So each term on a recursive is based on the previous term. So I'll let you guys keep going from there.